Good afternoon, students. This is a presentation on physics practical, Waec practicals based on past questions, based on past question 2026. Now, based on the apparatus given, we are provided with a return stand. Here's a return stand, meter rule. We have a meter rule, a spiral spring, plasticine, pointer, mouse, stopwatch, a mouse hanger. Here we can see the stopwatch. Here is the stopwatch or a stop clock. Here is the stop clock. We have the plasticine. The plasticine is holding the pointer. Here we can see the spiral spring on the mouse hanger. Then here we can see the meter rule. That's the meter rule. Then we see the two. These apparatus, they are arranged in this setup. We have two return stands in this arrangement. Now, in this arrangement, we are following the past question. We are going to follow it verbatim based on instruction. Here, we are told to clamp, instruction 1, we are told to clamp the meter rule vertically. You can see that in this arrangement, the meter rule has been clamped vertically such that the scale faces the pointer. The scale faces what? The pointer. Then instruction 2, suspend the spiral spring vertically. We can also see that the spiral spring is suspended vertically. You can detach it, you can also put it back. Then ensure that what it is in a vertical position such that the pointer attached to it with the aid of plasticine is pointing to the scale on the meter rule. Suspend a mouse hanger on the free end of the spring. That's instruction 3. That's a mouse hanger. So we have a mouse hanger that is suspended with the aid of the plasticine. So we suspend the mouse hanger with the aid of the plasticine at the free end of the spiral spring. So that is it. Then instruction 4, we are told to suspend the pointer horizontally on the free end of the spiral spring using the plasticine. You can see that the pin used as the pointer is placed horizontally such that it's pointing toward the scale. It's pointing toward the scale. So you can also adjust your meter rule such that it will exactly point to it. So that is it. Then instruction 5, we are asked to determine and record the distance L. The distance L. Now, if you go to the board, look at the board. The board shows the arrangement. The board here shows what? The arrangement. So on the arrangement, here we see return stand A and return stand what? B. The return stand B. The return stand A is holding the spiral spring such that the pointer is pointing towards the meter rule, which is what? This is the meter rule. That's the meter rule, which has the scale. Then between the upper end and the exact point where you have the pointer is L0. That's the initial position of the pointer before attaching a load using your scale hanger or mouse hanger. So that is that. So we go right to follow the instruction. Now we are told to add a mass of 150 grams. A mass of 150 grams. So we are starting with the experiment. So we have a number of experiments here. We have experiments. We have experiment 1. We are going to do it 5 times. We have experiment 1, 2, 3, 4. Experiment 1, 2, 3, 4, then 5. So this is number. So for experiment 1, the initial position of L naught here, the pointer, we can see that the pointer is pointing. Pointer, let's look at the pointer. On the adjustment, let me see. So the pointer is pointing exactly at what? 52. It's pointing exactly at what? 52. So the pointer is pointing exactly at what? 52. But for the purpose of this experiment, we can 51. So that's 51. So that's the initial point, 51.0. So we record 30 watt, 150 mass. Now these are various types of what? Masses. We have these ones, they are round masses, but there are other types of masses which are slotted masses, but we are not using slotted masses. But for this type of round mass, what we did is to attach string to hold it. We attach string by making a loop round the masses for easy work. So the first one we are taking 150, right? This is 100 standard mass. So we take the 100, we attach it to the pointer. Then we add additional 50. We add the additional 50 and allow it to what? Allow it to what? To extend. We allow it to extend. You can see there is free extension. Now that it has extended, remember the initial value. The initial value was 51. So what we did now is to let's see the value. Now the exact value here is what? Okay, let's work with the pointer. 50 gram. The extension is exact 41.5. So 41.5. So we record. So our L 1.5. So taking our extension now. So our extension becomes what? 51.0 minus 41.5. What would that be?
9.50.
9.50. So 9.50. So at this point, we follow the instruction. So let's take further instructions based on our past questions. So we have taken it says determine and record the new distance L of the pointer and evaluate E equal to L minus L naught. Then instruction A says pull the hanger gently downwards and release to set it to vertical oscillation. So meaning that we are going to pull the hanger gently. So we pull the hanger gently. 1, 2, 3, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what's your timing?
9.97.
9.97. So our timing is what? 9.97. Yes. What's your second timing?
9.00.
9.00. Now for accuracy, we are taking what? Time 1. We are using two timers, time 1 and what? Time 2. having 9.97, 9.00. So we find the average. Our T here equals to what? T1 plus T2 over what? 2. So when you do that, what do you have?
9.49.
9.49. So 9.49. So we have to evaluate T. T is called period. Period T is given by time T over our number of oscillation. Now the number of oscillation here is what? 10. That becomes our time T 9.49 over our 10. What will be the value?
0.994.
0.994. So we have to evaluate what? T square. Evaluate T square. When we evaluate T square, what would that be?
0.988.
0.988. Now, if you look at the board, as you can see, we repeated the experiment for 200 gram, 250 gram, 300 gram, and 350 gram. Meaning we did the experiment 5 times, and these exact values were obtained. Now, this is based on past questions, right? This is Physics Practical 2026 based on past questions. So let me read up the remaining part of the question so you can work with this value. Okay, we stop at instruction 8. Therefore, instruction 9, determine and record the time for 10 complete oscillation, which we have done. Then instruction 10 says, evaluate and record the period capital T of the oscillation and T square, which we have recorded on the table 5 times. Then instruction 11 says, repeat the procedure for mass N equals to 150, 200, 250, 300, and 350 respectively. He said, in each case, determine and record L and T, which we have done. We recorded the value of L and T. We decided to repeat T twice for accuracy. We did it first time and second time and took the average before we went ahead to evaluate the period and the square of the period as recorded in the observation table. Let me point out something here. We are told here that we should evaluate E, which is the small e, which is the extension, capital T and T square. Tabulate your reading in the space provided based on the past question. We are working with past questions. So these are the readings obtained so far. But for those of you writing the exam, physics, now listen. Based on the question we give you, know when you are presenting your table, certain rules are noted. Number 1, in each column, the decimal point must be what? Uniform. So if you are doing 2 decimal points, it must be what? Uniform. So you cannot start with 2 decimal points, unlike this one now, and have starting with 2 decimal points, then ending with 1 decimal point. Marks should be deducted from it, so you correct it. It must be what? 2 decimal point or true. Since you are having 9.50, so it must be what? 2 decimal point. So that is it. So if for evaluated values such as T and T squared must not be less than what? 3 decimal values. So that is that. So this is the table of values. I think with this alone you are sure of 10 marks for your table. But you can go to do other things that require of you, which is from this item now. We are told here in item 14, plot a graph of E on the vertical axis and T square on the horizontal axis, starting both axes from the origin 0, 0. Then 15, determine the slope of the graph. But for the purpose of just guiding you on what to do, here we are told that we have to plot a graph with E in centimeters as is distinguished with T square horizontal, which is our T square in what? In seconds. So that is that. So you are going to work with E You're going to work with this column and this other column. You're working with this column. Now look at the values here. Let me just quickly delve into what? Scale. How do you choose scale so that you can, for effective graph? They are positive what? Values. Being positive value meaning that it's very easy for you to plot this type of graph. The highest value here is what? 24. For a standard graph, it's about the spaces based on 2 centimeters, they're about 10. The space they're about 10. So conveniently you can use what? 2 centimeters on your graph is equal to what? 2 centimeters. Move on your graph, you get what? 2 centimeters. So if you spread, you can spread up to what? You can spread up to what? 22. You can spread up to 22 because the highest value here is 25 graph. There are forbidden rules. In choosing your scale, avoid using odd numbers. Avoid what? Using odd numbers. Odd numbers such as what? 3, 5, 7, and 9 and so on. So when you use odd numbers, the examiner does not need to mark for you. The examiner goes straight and what? Mark you down. But use even numbers such as your even numbers. These are odd, even, 2, 4, 6, 8, and so on. So when you use even number, it's easier for you to work with the standard graph. That's why I said you use 2 cm because to what? 2 cm for your graph, which is already standard, to 2 cm. So as you move progressively, it's very easy for you to work with such things. That's for E, 2 cm. That's E axis. E axis. For your T square axis, the highest value here is what? The highest value is of 1.053. So it's also convenient for you to do 2 centimeters. The highest value is what? 0.2. Such that when you move 0. Look at it. 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. When you start with this 0 already, 0.0, 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.18. You see? So when you work like this, you see that everything with every number, the values you are looking, all these values from experiment 1, 2, 3, 4, 5, they will all fit inside, and you will take your point. So it's very easy for you to do. Well, for further insight into how to plot graph, you can go to for further insight on how to plot graph, you can go to my YouTube channel, the Physics Oracle. Go there and you see how to plot graph for Waec physics practicals, and you get a very good insight on how you can plot your graph. Good day.